Hi everyone, we are going to do minors and cofactors today. First of all, I would like to tell what minors are and how many minors are possible. I have taken a determinant of the order 3. So over here you can see there are 9 elements. You can call it as 3 by 3, you can also call it as by 3 because we always take the determinant of a square matrix. So for matrix it is a 3 by 3 matrix, so we can call a determinant of order 3. And if a matrix is of order 2 by 2, we can call it as a determinant of order 2. So over here there are 9 elements. So how many minors will be there? There will be 9 minors because we can find out the minors for each and every element. Like over here we can find out the minor of element 1. I hope you all remember this is row 1, this is row 2 and this is row 3. Over here this is column 1, this is column 2 and this is column 3. So the first element, usually in general we write the first element as A11, A12 and A13 and so on. We write all 9 elements. So if I ask you the minor of element 1, it means we can name it as M11. Now how do we calculate that? You will hide the first row. This stands for row and over here this stands for column. So you will hide the first row and first column and you will find out the determinant of the left element. Everyone please keep a finger on the screen. Just hide the first row and the first column. The elements which you are left with are 5, minus 1, 1, minus 2 and do cross multiplication. This is 5 2s are 10 minus there is one more negative sign, so it will be negative 1. It means that is going to give you 11. So what is minor? Have a look at the definition. Minor, which you name it as Mij, is the determinant obtained by deleting ith row and jth column. So that's the minor. Let's calculate some more minors so that you should be clear with this. Let's do minor. Now you tell me what is minor of M21. Which row are you going to hide? You are going to hide the second row. I'm just doing it here. Second row and the first column. You can do it like this. Second row and the first column and then take the determinant of that. So let's do the determinant. So hide the second row and the first column. You're left with 0, 4, 1, minus 2. Do cross multiplication. So 0 into 2, that is 0. So you are getting it as minus 4. So that is M21. If you are done with minors, so similarly you can calculate minors for all the elements. I'm telling you for one more element, say M31. Say M31. So hide the third row and the first column. You're left with the elements 0, 4, 5, minus 1. Over here, minor is coming out to be minus 20. Now I'm going to tell you about the cofactors. How you are going to calculate cofactors. Cofactor usually you denote as C11 or you can also write it as capital A11. So there is only a minor difference between the minors and the cofactors. What is cofactors? Have a look over here, the definition. Cofactor, which you call as Aij, it is actually equals to minus 1 raised to the power I plus j into Mij. I'm explaining you here. This will be minus 1 raised to the power sum of the prefix over here, that is 1 plus 1 into the minor. Minor you have already calculated into the minor. You have already calculated. So it is minus 1 raised to the power 2 into 11. It means this is also 11. So have a look again. Minor was 11 and the cofactor is also 11. What do you have to do? You don't have to do this every time. You only have to do the addition of the prefix. If the addition is coming out to be odd, over here it is even. So if it is even, the sign will not change. But in case if it is odd, say in this question, say in question number, over here this example, C21. So what will be C21? that will be minus 1 raised to the power 1, 2 plus 1 into m21. So it will be minus 1 raised to the power 3. So you will get a negative sign. So there is one more negative over here that is going to make it positive. So have a look again. Minor m21 was negative 4 and c21 is positive 4. So what have you understood? You have understood that there is one minor difference between the minor and cofactor, and that is of the sign, whether there will be extra negative or not. M31. So what will be the cofactor? What will be C31? Do the addition. 3 plus 1 is 4. That is even. So sign will not change. This will be same. This will be negative of 20 only. Can you tell in how many elements you will have extra negative? See over here. This is say minor m11, over here m12, m13. So this will be negative. If you will find out the cofactor, you will get a extra negative sign, right? For this one, m21, 2 plus 1, so extra negative here. M22 will remain with the same sign. 2, 3, again extra negative. Then 3, 1, 3, 2, 3, 3. So if you are going to find out the cofactors, so cofactor for this element, for this one, and for M23, if you are going to find out the cofactor for C23, you will get one extra negative sign, because 3 plus 2 is 5, and which is odd, so you will get an extra negative sign. So I hope you have understood the definition also, that minor is the determinant obtained by ith row and jth column, and cofactor is minus 1 raised to the power I plus j into mij. Now if you have done this, let me clear the canvas. I'm going to tell you about the adjoint now, because adjoint is also very, very important. And you know the concept of if you know the concept of minor, cofactor and adjoint, you can solve one 6-marker question, which is 95% of the time is tested in the exam. So let me tell you what is adjoint. Adjoint, which you write as adjoint, say, of a matrix A. A matrix is given to you. Let's take example. A matrix is given to you. Say this is a matrix. Let me write down any random matrix. 1, minus 1, 2. I'm taking 3 by 3 matrix. 2, 3, 5, minus 2, 0, 1. This is a matrix given to you, and I'm asking you to find out adjoint. Now what is adjoint? Adjoint of a matrix is actually the transpose of the cofactors. What? Transpose of the cofactors. Alright, let's calculate adjoint of a matrix. Adjoint of a matrix is calculated for the square matrix. You can calculate for 2 by 2, for 3 by 3, for 4 by 4, and so on. So what is adjoint? That is the transpose of the cofactors. So let's calculate the cofactors. What is A11, what is A12, A13, and so on. A11 means hiding the first row, the determinant obtained by hiding the first row, and first column. This is stands for row and column. So let's do that. So this is going to give you 3. So let's write it 3 over here. A12, you will get one extra negative. So hide the first row and the second column. So that is going to give you, hide the first row, put the fingers on the first row and the second column. So that is going to give you 2. See, have a look here, just put a finger over here. So that is going to give you minus of 2 and negative 10, and it will become positive. So this will be minus of 12. Now put a finger on the first row and the third column. So that will give you 6. So that is going to give you 6. I'm not doing for all the elements. I'm just writing directly. A21, A22, A23, and 31, 32, and 3, 3. I'm writing them directly. A21, 3 minus 12 and 6. So 1, 5, 2, minus 11, 1, minus 1 and 5. So now the last step. What is the last step? After finding out the cofactors, what do you have to do? You have to take out the transpose. So let's do the transpose of these elements. That is going to give you the adjoint. So adjoint A is actually the transpose of the cofactors. So 3 minus 12, 6, 1, 5 and 2, minus 11, minus 1 and 5. How do you do the transpose? You change the rows into columns. So the first row will become the first column and the second row will become the second column. The third row will be the third column. So that gives you the adjoint of a matrix. I will also tell you how do you calculate for 2 by 2. Take any other example. Say B is a matrix 1, 2, 3, 4. Calculate quickly C1, A11, or you can also call it as C11, another way of writing it. Hide the first row and first column. What are you going to get? You are going to get as 4. What is A21? A21, hide the A12 over here first of all. A12, hide the first row and the second column. You're getting 3, but you will put extra negative. A21, I hope you remember, extra negative. So 21, that is going to give you minus 2, and A22 is going to give you 1, because you will hide the second row and the second column. You will hide the second row and the second column, so that is giving you 1. Now what will be adjoint of this matrix? Adjoint will be the transpose of the cofactors. Write down the cofactors: 4 minus 3 minus 2, 1. And now have a look here. You are getting 4 minus 3 minus 2 and 1. Have a look at the given matrix. The given matrix was this. I'm using yellow pen. This is the given matrix. So see, you have interchanged the places. These places you have interchanged in the answer. Look here. And these ones you have changed the sign. You have simply changed the signs. It was positive 2. These ones. Positive 2, you have written a negative 2 over here, and over here negative 3. So you can write it directly also, rather than applying this traditional way if it is a 2 by 2 matrix. But yes, for 3 by 3 you have to solve. We also want to do inverse. So inverse maybe we'll do in the next video, and the properties of inverse. Thank you. Bye bye. That's all for today.